You know that feeling when you ask an AI to make a plan? It's like you're talking to this brilliant, super creative person who comes up with these amazing ideas, but the details, oh man, they're often a total mess. Well, today we're going to look at a brand new framework that basically acts as a smart, logical manager for that creative genius, and it turns those wild ideas into reliable, rock-solid plans. So what is the core issue here? I mean, you've probably run into this. You ask an AI to plan a trip, and it confidently suggests a flight that doesn't even exist, or a budget that's just completely out of touch with reality. It's this common frustration that makes these incredibly powerful tools feel, well, kind of flaky for really important tasks. The big question is, why? Why are they so good at some things, but so bad at this? And it really is a strange paradox, isn't it? An LLM can whip up a beautiful poem about Paris in seconds, no problem. It can summarize a super dense scientific article with total ease, but ask it to plan that 5-city trip across Europe with all the messy flight constraints and a hard budget, and it just hits a wall. They are absolute masters of creative language, but they really struggle when you box them in with rigid logical rules. Well, it turns out the fundamental problem might be how we've been approaching this all along. See, we've been asking these AI planners to be perfect little logicians, to give us that one single optimal answer right on the first try. That's kind of like asking a brilliant artist for just one single brushstroke and expecting a masterpiece. It might be genius, or it might be completely impractical. There has to be a better way to tap into that creative power without getting led down a dead end. And that better way, it turns out, comes from a really unexpected place: robotics. Yeah. Instead of trying to force the LLM to be something it's not, researchers looked over at control theory, the science behind how robots and self-driving cars navigate the messy, unpredictable real world, and they found a whole new approach. The key concept they borrowed is something called Model Predictive Control, or MPC. And don't worry, we're not going to get bogged down in the math here. The absolute best way to think about it is like a self-driving car. It doesn't calculate the entire perfect route to your destination in one go. No way. Instead, it's constantly looking just a few seconds ahead, planning a short little path, driving for a moment, and then bam, immediately reevaluating and replanning from its new position. It's this continuous loop of plan, act, check, and then do it all over again. And this right here is the core idea behind the new framework they built, LLMPC. It's Large Language Model Predictive Control. And what it does, essentially, is it pairs that creative, brilliant LLM, our brainstormer, with a super strict logical manager that keeps it focused and on track. So here's how it actually works. First, instead of asking for just one plan, you tell the LLM to brainstorm a bunch of different ideas. Then, the manager, which is just a logical bit of code, scores every single one of those plans against your rules. Think of it like a really strict checklist. Did it stand budget? Yep. Are the flights actually possible? Uh-oh, nope. The plan with the fewest problems gets the best score. Then, and this is the really clever part, the system only executes the very first step of that winning plan. And as soon as it's done, the whole process starts over from this new spot. It's a constant cycle of generating creative ideas and then checking them against cold, hard reality. Okay, so the theory sounds great, right? But does it actually work? Well, the researchers put LLMPC through its paces with 3 very different and very challenging planning problems to see if it really holds up. The first challenge was a real doozy, a classic physics problem about precisely controlling a spring and mass system. This is a tough, super mathematical test. It's designed to see if this new language-based approach can even come close to the kind of precision that traditional old-school algorithms are known for. And the results are, well, they're pretty dramatic. Look at this. When the LLM generates just one plan, the standard way, its solution is over 8 times worse than the perfect answer. But check out what happens when you let it brainstorm just 15 different options. The quality just skyrockets. The final plan is only 1.3 times worse than the mathematically perfect solution. I mean, that's incredible. It's clear proof that just letting the AI brainstorm makes a massive difference. All right, now let's move on to something we can all relate to a little more: trip planning. This is a notoriously hard task for AI because of that tangled mess of rules about flights, hotel stays, budgets, and all those specific date constraints. And here, the power of that iterative loop is on full display. A standard single-try approach with GPT-4o, it only managed to create a valid plan about 14.5% of the time. That's not great. But By using the LLMPC framework to propose, get feedback, and refine the plan over and over, the success rate more than tripled to almost 45%. That is a huge leap. The final test is maybe the most complex of them all, scheduling a full day of meetings all across a city. This means you're juggling location, travel time, every single person's availability, and how long each meeting needs to be. It is just a dense web of constraints that can easily trip up any AI.
And once again, we see another huge boost in performance. The standard approach? It succeeded about half the time, which is okay. But the best performing LLMPC model, the one that combined brainstorming multiple plans and refining them iteratively, solved the whole puzzle 67% of the time. This really drives the point home. It's the combination of these two strategies that's the key to unlocking these really complex planning problems.
So, what does this all mean? What's the big picture here? The crucial takeaway is that this isn't just a minor incremental improvement. This framework suggests a fundamental shift in how we should be working with AI for planning. It's really about creating a new kind of partnership between the AI's amazing, human-like creativity and the machine's relentless logic.
So to sum it all up, this really changes how we should think about these models. They aren't just text generators, they're creative problem solvers. The secret is to let them brainstorm, to let them explore multiple options, instead of demanding one perfect answer from the get-go. And by putting them in that iterative loop of planning, acting, and replanning, we can get these incredibly robust, high-quality solutions. LLMPC gives us a blueprint for a powerful hybrid system that really does get the best of both worlds, the flexible creativity of language models and the logical precision of classical algorithms.
And this all leaves us with a pretty powerful question to chew on. For years, this kind of complex rule-based planning has been a major weakness for AI. But if an AI can now effectively brainstorm, evaluate, and refine its own plans, a lot like a human expert would, what's the next so-called impossible problem that's about to be solved?